So one of the two ways that we mark up data is XML, the other JSON. First we'll talk about XML. We'll talk about XML more for a longer time than we talk about JSON. XML stands for Extensible Markup Language. There was a number of markup languages in the 90s that were out there, ways to send data between computers, and none of them was like amazingly better than the other, but in the early 1990s, as HTML came out, the idea that we could use less thans and greater thans, you know, or angle brackets, some people call them. Once HTML made angle brackets popular as a representation format, it was pretty natural that we would find a data representation format that would take a similar approach. And so inside XML, we're going to talk about tags, we're going to talk about attributes, we're going to talk about data, and we've already talked about serialization and deserialization. Serialization is the act of taking data inside of a computer in one programming language, setting it up for transport, transporting it across, and then taking it back apart and turning it back into the data in whatever internal data it needs to be in the destination system. So here is some basic XML, so we can take a look at the various things that make up the XML. So it's very much like HTML in that we have tags, less than, greater than. The difference is we get to name the tags anything we want rather than the A tag or the P tag or the H1 tag. And there's a beginning tag and an ending tag, and they're bracketed together. And there's syntax errors in XML. Syntax errors in XML are more severe than syntax errors in HTML. It's supposed to be right, and if you send bad XML, it's likely that the far end will not understand it. So we have a beginning tag and ending tag, and so like name and slash name are a beginning and ending pair. Then there is the actual textual content, and that is the material between it. And then here's a phone and slash phone, and we have this thing called the attribute. Key equals value. The key doesn't have double quotes. The value always has double quotes, and this is like href equals on an anchor tag. And sometimes you have what's called a self-closing tag, where you don't actually have a closing tag. You have all the data that you need in the attributes, and so you don't even bother putting an empty text area in a closing tag. So that is a start tag, an end tag, attribute, and then a self-closing tag. Those are some basics of XML. In general, XML doesn't care too much about white space. It does in the text areas, so in here it matters and here it matters, but things like we can indent this a little bit differently, and we tend to indent it in a way to make it look reasonable. Although once you have programs sending it back and forth, they tend to send it more compacted just for efficiency purposes. So one of the concepts is that there is a hierarchical structure within an XML document, and there are parent nodes and child nodes, and you can think of these as simple nodes that is a tag and some data, or a complex element that has a tag that includes other tags, some child tags. And there's a couple of different ways we can take a look at this. The simple and more natural way to think about this is a tree with parent-child relationships. So here we have this A tag on the outside, and that's the top level one. You can only have one outer tag, and you can't have, you know, another tag down here. So you have to have one tag that's sort of the root tag for everything in this XML document, and it has two children. So the C tag and the B tag are two children. So the B tag is a child of A, and then C has a D and an E tag that are children there, and then the textual data we model as a child of each of those tags, and you'll see in a bit why it's best to do that. So that is the way to think about this as a tree, to represent that XML as a tree. If we add attributes to it, and this is where you kind of see why it's nice to take the text area and make that be a child of the node, an attribute is a different. So the text is a special kind of child, and you can literally have more than one attribute. You could have x equals 2, you know, zap equals whatever, and these could have a couple of different attributes. The W attribute is a value of 5, and that's the 5 down there, and so you could have multiple ones. You can only have one text node. Now, in the case of A, you have a whole bunch of text nodes, but these are because there are child nodes. Within one simple node, you can only have one text element. You can also think of XML as paths, and the easiest way is to sort of look down this tree version and look at from the path from the parent. So you go to A, then the child B, and then X. So at position AB, you find X. So AB is the path up to the root. So ACD, that's this one, is the path to Y, and ACE is the path to Z. And so you can think of these as paths. Part of what we're doing is we're coming up with ways to walk through and parse trees of XML data. So the next thing we'll talk about is how we determine if a particular XML document is legal or meets the contracts that two applications have set up.